Our society has become deeply dependent on digital devices. But how do they actually work and why do we call them digital devices? To understand that, we first need to understand the computer, the foundation of all modern smart devices. Every personal computer has five main components, like parts of the human brain and nervous system. All of them are connected and work together. Each component has its own role. Let's quickly explore each one. Motherboard, the foundation. The motherboard is the foundation that connects all other components together. Think of it as a giant city map filled with electrical rods called fuses. You can imagine them as highways inside the computer that carry electrical signals representing binary ones and zeros, something we will explain a little later. The motherboard's main job is to provide a place for every component to connect and communicate. If the motherboard fails, the city loses its rods and everything becomes disconnected. CPU, the decision maker. Once the computer is powered on, the CPU starts working. It is the part responsible for processing instructions, which is why it's called the central processing unit. The CPU acts like the brain of the computer. It constantly processes incoming information from other components and sends instructions throughout the system. Without CPU, the computer has power but no direction. While the CPU is fast and powerful, it has no space to permanently store information. That's why it needs RAM. Think of RAM as a desk. The bigger the desk, the more peppers the CPU can work with at the same time, without having to reach down into long-term storage. Storage, the warehouse. Storage is like a warehouse or office archive where inactive data is kept. This is where your files live when the computer is turned off. Unlike RAM, storage doesn't need constant electricity to keep your data saved. When you want to do something, the data travels from storage through the motherboard's routes into RAM, so the CPU can use it quickly. Without RAM, the CPU will not have fast access to the data it needs. And without storage, nothing will remain after the computer is turned off. Everything will be lost. GPU, the visual system. While the CPU is the brain that makes decisions, you can think of the GPU as the eyes of the computer. The CPU tells GPU where to look, and the GPU processes and renders the image or video you see on the screen. Without it, nothing you see on the screen would exist. Imagine you are playing a video. Motherboard sends your mouse click signal to the CPU. CPU sees the click and says, "Okay, we need to play this video. Storage sends the data." Storage sends the video data across the motherboard rods. RAM catches the video data and holds it so it's ready to use. CPU reads the data from the RAM and tells the GPU how each frame should look. GPU draws the frames and sends them to your monitor. But there is a question: what are those signals that these components use to communicate with each other? When humans exchange information, we use words. I can tell another person, "Please give me a cup of water," and they understand me and give me that cup. But computer components communicate with electrical signals, which we call binary. The language of binary. In computer language, there are only two symbols, 1 and 0. This represents with a transistor, which is like a switch that can be on or off, receives a signal or not. The motherboard sends an electrical pulse to the CPU. The CPU transistor receives this, turns on and translates it as a 1. If the motherboard sends no pulse, the transistor stays off and translates it as a 0. 1 bit represents 1 electrical signal. In a modern computer, there are billions of transistors that translate massive amount of high bit information. To clarify, if I write subscribe to this channel for you, the computer translates these letters into the "this" numbers. If you add an animation to these letters or a background, it requires even more bits, because every pixel and movement must be represented by its own unique binary code. Now, imagine how AI agents work. Think about the massive, endless oceans of binary code they are decoding to generate videos or images out of thin air. AI struggles because of the huge data size, but also because it's thinking and deciding exactly which numbers to place into the pixels to mimic our reality perfectly. But here we face a mystic and darker question. How can a machine begin to think by itself? What's happening inside the digital mind when the lights are off? Is it possible that we are no longer just building tools, but breathing life into a phantom intelligence? How dangerous is it that here on Earth we are creating a ghost in the machine, an entity that can already think faster, deeper and better than any human who ever lived?